The other day, actually, that I need, they sell those big tubs at Sam's. I think I'm going to get them next year and keep them at the top. When people start to fall asleep, I'm like, fill them with it. Okay. All right, here we go. So polar coordinate, it's what they tell you to eat like whenever you're driving on long trips. You get tired or whatever.
It's funny because I love mint.
Yeah, eat it.
I always have
Oh, yeah. No, the peppermint patty is for you to enjoy and eat. It's not, we're not calculating anything about it. It's just to make your mouth cool and polary. Okay, so here we go. Polar coordinates and graphs. We talked a little bit about it the other day, right? That this is a polar grid. And whenever you graph polar coordinates, they're listed as what? R theta, the radius, and then the angle. But what do you have to graph first? Or what do you have to look at first? The angle, right? You have to look at the angle first whenever you're going to plot a point. Okay, so look over here. If I want to graph the point 3 pi halves, okay, how do I graph it? I go to pi halves, right? Here's my origin at 0 degrees or at 0 radians, and I'm going to go to pi halves. This should be in radians, but I couldn't find one that was in radians. So I'm going to go to pi halves, and then I'm going to go out 3 units, right? And actually, I should have make this point P, and we'll label it right there. So do you remember that? How to graph a point?
Yeah.
Okay. So, just recall, rectangular coordinates we know are x, y. Polar coordinates are r, theta. Do you remember these things? That to convert from rectangular to polar and vice versa, you have to understand that x is equal to r cosine theta, y is equal to r sine theta. These are all things that you learned in pre-cal. That I know that the radius is equal to the square root of x squared plus y squared. And then I know that the tangent of theta is y over x, right? This would be to convert from rectangular to polar. Okay, and then you can solve for theta. So go back over here. Let's finish graphing. What does r equals 5 look like? That's a circle, and it has a radius of 5, right? So I would just go out 5 units from the pole. And I would draw this circle, right? Do you remember that?
Yeah.
Yes? It's not as good as Miss Traeger. Okay, what about theta equals pi 6? What's that look like? That's a line, right? So I would go to pi 6, which is right here at 30 degrees, right? And I would go out this way, but what other way? I have to follow it all the way out, right? Do you recall that there are multiple ways to name points when you're talking about polar?
Oh, yeah.
So like this is 3 pi halves. Can you think of another way you could label that point? 3 pi halves, negative 3, right? Or sorry, it would go negative 3 pi halves if you order it the right way. Okay, because you have to list it as r theta. Okay, or what?
3 negative 5.
3 5 pi halves, yes. And what did you say?
Wouldn't it be negative, or 3 negative 3 pi halves?
That's right.
Yeah.
I'm talking about point P, right?
Yeah, point P. Did I say something wrong?
What? No.
No, I was just making sure.
Oh, okay. But what did you say?
3 negative 3 pi halves.
3, yes, negative 3 pi halves, right? Okay, good. All right. So hopefully all that, sounds familiar. So what about this first example here? Convert 2 5 pi 6 to rectangular coordinates. So 2 is r, 5 pi 6 is theta. So if I want to convert this to rectangular, that means I need an x and a y, right? And what do I know x is? Good. So x is r cosine theta. So x would be equal to 2 times cosine 5 pi 6. So you're going to have to remember some trig here.
Negatives.
So
Negative square root of 3, right?
Yes.
cosine of 5 pi 6 is negative square root of 3 over 2. So 2 times that would be negative square root of 3. I'm not losing anybody, am I? No, okay.
Not yet.
So y is our sine theta. So y is 2 sine 5 pi 6. So what's y? 1, right? Because it's 2 times a half. So the polar coordinates are, I'm sorry, the rectangular coordinates are negative square root of 3, 1.
Oh, wait, yes.
Right.
I was looking over the-
That's okay. You're good. Okay, so what happens now if I want to convert this rectangular to a polar?
Inverse tangent or negative.
Right, I need to figure out what r is. I know that r is equal to the square root of x squared plus y squared. So r is equal to the square root of 18. Yeah, so I know that tangent of theta is equal to y over x, right? So tangent theta would be equal to what in this problem? Negative 1. And tangent is defined from negative pi halves to pi halves. So where does that occur?
Negative pi.
Yep. Negative pi fourths. So how do I list the ordered pair?
Square root.
Square root of 18, negative pi fourths, right? Okay, so the first 2 examples had to do with coordinates, converting them. Now I'm actually converting equations from rectangular to polar form. So I know y is equal to 4. What else do I know y is equal to?
R sine.
Right? So r sine theta is equal to 4. Now when you're writing a polar equation, what does it start with?
The angle.
The r, right? A polar equation starts with r. Like if you go to your calculator, right? If you put your calculator in polar mode, and then you go to y, oh, that's not in polar mode. And then you go to polar mode, it starts with r equals. Okay, so that's how you want to solve any polar equation. You just go to mode, switch it over to polar. All right, so if I want to solve this for r, I get that r is equal to 4 over sine theta, which you might also see written as
Or cosine.
4 cosecant theta, right? Yeah, so, okay, so in part B, remember I want to go to polar form. So I need it to say r or theta, right? What can you do here?
Well, just take this.
Square root of sine.
Okay, or r squared is equal to x squared plus y squared, right? Okay, you're saying the same thing. So I replaced this with r squared is 25. So r is equal to plus or minus 5. So the challenging part is to remember how to graph these things. Yeah. Gross. Okay. So the next one, convert the following equations to rectangular form and sketch the graph. All right, so I want to now write these in rectangular form. Well, what's r sine theta equal to? Y equals 3, right?
There you go.
That's a pretty easy graph. What is it?
It's a one.
It's a
Horizontal.
horizontal line that goes through 3.
All lines are straight.
All lines are straight.
Except for
What about the next one?
Yeah, together. You have to like redefine R.
I do have to redefine r. So
X over cosine.
you suggested making it be get the cosine over there, but if I divide by cosine, I don't have cosine anymore, right?
Yeah.
So what else could you do?
So you could say R is the square root of X.
You could.
Squared.
You could say r is the square root of x squared plus y squared, and that would equal to cosine theta. Not sure that's getting me anywhere.
Yeah, I mean, can we make it be X over cosine theta? Does that help us more, or does that not?
X over cosine theta. What are you missing right here?
Well,
No, what are you missing where you could like redefine this side? An R, right? If I had an R right here,
add R to both sides.
yeah, so if I multiply this by R and I multiply that side by R, then I get R squared is equal to 2R cosine theta.
Which is 2.
That's helping me out now, right?
Like that.
Because this is x squared plus y squared is equal to 2x.
How do we get there again? Can you explain that?
I multiplied both sides by r. Because when I did that, that gave me this r cosine theta, which I know up here by definition is x.
Oh, and
Yeah.
R squared. Okay.
And r squared I know is x squared plus y squared. Okay. All right, so I'm supposed to graph this thing. Huh. What do you remember about this?
You just square solve for y.
It's a circle with a. It's part of a circle. Semicircle. Next question.
Well, I tell you what. This is the conic section.
Oh wait. Next question. What about it?
Oh,
Hurts. Right in the layers.
All right, so do you remember how to complete the square?
Isn't it like
You
divide by two?
Divide by 2 and square it. So what am I putting on this side?
Divided by 2.
The middle term, right? That's how you complete the square,
Oh.
right? So this becomes a plus 1, and if I put a plus 1 on that side, I have to put a plus 1 on this side. So this becomes x minus 1 squared plus y squared equals 1. What's that an equation of?
Circle.
That is a circle. That is a circle
Right line.
that has, where is it centered?
0, -1. Or
1, 0 is its center. And what's its radius? 1, right? So 1, 0 is the center. Radius is 1. I'm going to do my best Sharon Strager.
Oh, look at that.
There we go. It's pretty good.
It's distorted. One second. Do it again.
Jeez.
It's the L.
I'll never live up.
The L was the
That was-
That was Randy, right?
All right. What about this one? I need to go to rectangular, so I need x's and y's. I got a theta in there.
You can use tangent.
Okay? I can use tangent how? What am I going to do?
Tangent by thirds.
Tangent of both sides, right? Take the tangent of both sides. So I'd have tangent theta is equal to tangent 2 pi thirds. I know tangent theta can be replaced by what? Y over x. And what is the tangent at 2 pi3? Gross.
Square root of 3.
Yeah, square root.
Negative square root.
Negative.
Square root.
Dang. Whatever's. Don't need it.
So y is negative square root of 3x. So what's that the equation of? A line with a slope of negative square root of 3. Who cares?
You just, whatever.
Whatever. Okay, so there's some basic review.
Dang, I was hoping that was it.
No.
Yeah, that is.
Okay, so this is part of what you're gonna do tonight and tomorrow. But I want you to go to this page. Go to page 7.
The radius.
Go to page 7. Okay. So if I need the slope of a tangent line to a polar graph, I get to use the fact that x is equal to r cosine theta and y equals r sine theta to come up with dy dx is equal to dy d theta over dx d theta. Right?
Makes sense.
Yeah, I mean it makes sense, right? Just like for a parametric, dy dx would be dy dt over dx dt, right? The bad part is that you've got product rule in here, so it's pretty nasty. But I've got faith in you. Come on, we can do it. Remember, I told you 3 days. 3 days, people, 3 days.
That's true. And a weekend too. Like a whole month though.
Okay, here we go.
3 days is
So dy d theta using the product rule, right? So I need to do the first times the derivative of the second plus the second times the derivative of the first with respect to theta. Dr d theta.
Doctor.
Okay, over, and remember these are independent of one another, right? There's no quotient rule or anything here. Okay, so now I need to do dx d theta. So I'm going to do the first times the derivative of the second. Yep, and I'm going to put the negative out in front of the r, right? Plus the second times the derivative of the first. Okay? So, some people, I don't know, choose to memorize that formula. I just recreate it because I can't memorize that. That means nothing to me. Okay? Okay. So let's do this example. Find dy dx and the slope of the graph of the polar curve at the given value of theta. Okay, they have asked you for dy dx. Now please be aware that sometimes a question might ask you for dr d theta. Okay, in which case we're not talking about this, but dy dx, we got to do dy d theta over dx d theta. Okay, so here we go. Are you ready? All right, so dy dx okay, so here's what I know. I know that x is equal to r cosine theta, right? So x is equal to, what's r? 3 plus 2 sine theta times what?
Oh, God.
And y is equal to what?
R sine theta.
R sine theta. Which means that y is equal to
3 plus
It's a little early. Oh, that's easy. Just take
Wait, just-
we have.
We have
They all cancel out.
okay.
Would you like to switch to
Yes, it is.
It's a-
Okay, so go look at this definition. Okay. All right. So by definition, it's r cosine theta. What's r cosine theta?
Oh,
That,
that,
right? It's that.
that's not that bad.
No. So I have 3 plus 2 sine theta cosine theta plus
Sine theta times
sine theta times dr d theta.
2 cosine theta.
So what is dr d theta? Yeah, the derivative of 3 is 0. The derivative of 2 sine theta is 2 cosine theta. All over.
2A.
So I just snorted. Okay, so r sine theta, and it's supposed to be negative, right? So what is r sine theta? That. So negative 3 plus 2 sine theta sine theta
And this is all negative over 2.
plus, well, it's just the first term is negative, just the r. And then plus cosine theta dr d theta, which is 2 cosine theta. And where do I want all of this?
6.
When theta is pi 6. So, what time is it?
You have 2 minutes. Go.
Yeah.
So the answer.
Sine of pi 6 is
1/2.
half times 2 is plus 3 is cosine at pi 6 is
Square root over 2.
plus sine at pi 6 is 1/2 cosine, and this is square root of 3, right?
Oh,
All over negative sine there was square root of 3 over 2, right? So what is this?
Negative square root.
It's 3 plus square root of 3, right?
Isn't it the same as?
isn't
No, it should just be.
Oh, my bad, my bad, my bad, my bad, my bad, my bad, my bad.
Just sign, so.
Sine of pi 6.
Hang on, I'm sorry.
It's 1/2. So
It's 2.
3.5.
Just 2. 2.
Yeah, once you try to take 2 right there.
I don't know what we're fighting about.
How is it not the same as the thing on top?
But the one on top, I
What?
think is 3 plus. We do it wrong.
3 plus 2
Because
sine
isn't
theta?
sine-
But then times
Okay, back up here. This was square root of 3 over 2, right?
No,
No, it's 1/2.
1/2. That's my problem.
So that's 1/2.
Here's the stinking answer. Okay, so here's what I want you to do tonight. If you look back here on this worksheet, we're going to do, it's the very last page.
30 problems on there.
We're going to do 1 through 10 and 12. 1 through 10 and 12.
So everything but.
Yeah, just omit 11 for now. It's the very last page in the packet. What's that? Yes, you will need this packet tomorrow. Bring it tomorrow, okay?
No.
Is there anything else for tomorrow? Because I won't be.
No, you want that. Yeah.